Welcome to Conway's Game of Life, a fascinating example of a cellular automaton. Although the rules of this game are simple, the patterns that emerge can be incredibly complex and beautiful. The rules are easy to understand. Each cell in a grid can be in one of two states, alive or dead. The game progresses in discrete steps, called generations. Cells are updated according to their current state and the states of their neighbors. A cell is born if it has exactly 3 living neighbors, and a cell survives if it has 2 or 3 living neighbors. Otherwise, it dies. Despite the simple rules of the game, the patterns that emerge can be complex and fascinating. You may see still lifes, sets of cells that do not change over generations. You will also encounter oscillators, cells that form periodic patterns. You might even see a spaceship, a group of cells that translate across the grid on their own. We've created a comprehensive guide to Conway's Game of Life that includes everything from the basics to some of the most advanced patterns. Later on, we also highlight a few real-world applications that relate to this game. Here, we made a tutorial that allows you to explore the rules of the game and discover different types of patterns. Our 2 sandboxes allow you to experiment with your own custom starting points and rule sets to see what kinds of patterns emerge. It's like a digital petri dish with you in control. Finally, you will discover real-world applications of Conway's Game of Life. This includes disease transmission modeling, migration patterns, and even art and media. It's a testament to the power of simple rules and emergent behavior. With our website and visualizations, you'll be able to dive into the world of Conway's Game of Life and learn about some of the most amazing patterns and applications. Take the first step in exploring the complex world of the Game of Life. Delve into the intricacies of this cellular automaton and discover what patterns lie within. Who knows? Your exploration may lead to a breakthrough that could revolutionize the world.